OpenAI's ChatGPT has taken over the AI landscape as a powerful large language model. But behind the great big bang of ChatGPT, there's a 30-year history that transformed neural networks into what they are today. Let's reveal it all. The 2022 release of ChatGPT made waves like a cosmic explosion throughout the world of computer programming. For many years, AI programs were good at specific tasks, but they struggled to understand things in a broader sense and come up with creative ideas. ChatGPT changed this by being able to have open-ended conversations, write different kinds of creative text, and even write code. This made people question what it meant for a computer to be able to think, and its impact is still being felt today. It has led to a lot more research and development in AI, but its influence is not just limited to coding. It also affects education, entertainment, and even customer service. The thing is, ChatGPT wasn't just a new piece of technology, it was a total game changer for understanding language. It passed the Turing test, meaning it could communicate like a human and do things that were thought to be impossible for machines. And the way it was conducted was simple too. Imagine 3 chat boxes. You're in one box, while there's a human in another one nearby. That box is also talking to you, while another box, with a computer, is also holding a conversation with you. Now the thing is, you don't know which box is which, so you ask questions to figure out which box is the computer. If the answers were generated by a computer, but your answer was human, the computer actually considers that a win because it's nails talking like a real person. This is the crux of artificial intelligence. But it was in 1950 that things really kicked off for artificial intelligence. When Turing and McCarthy made big contributions that got the AI field going, they helped us start thinking about how machines could be smart like us. In 2018, GPT-1 was the first language model released. It was able to understand and respond to prompts and did the job, but then engineers decided to make it bigger and smarter, like GPT-2 and GPT-3, which got really popular. In fact, people liked GPT-3 so much that it quickly became a big deal, with millions of people using it to chat online. However, even after ChatGPT+ came out, there were some concerns about how these models handled data, and some countries put restrictions on them. OpenAI tried to fix this by giving users more control over their conversations used for training, but they didn't just stop there. They made apps for phones and even got into making AI that can generate images. Despite the strides it's made in AI, it took years and years of research to get to where it is today, and to understand that, we need to take a look at how neural networks transformed. Early neural networks were like experts in specific tasks, but struggled with flexibility. These siloed networks excelled at certain jobs, but couldn't adapt easily to new ones. ChatGPT changed this by combining various skills into one system. Instead of having separate networks for each job, it became a jack of all trades, understanding different languages and topics. This shift from specialized to general-purpose systems made ChatGPT more versatile, handling diverse tasks. But before, these networks were like specialists who couldn't do much else. This all comes down to how the large language model was able to learn, and it involves a concept called sequential learning. Sequential learning requires understanding information in a step-by-step manner, like reading a story where each part builds on the previous. Recurrent neural networks are smart systems designed to handle this kind of learning, remembering past steps while considering new ones. They're like remembering the context of a conversation to keep it flowing and follow trajectories through different stages of understanding, just like ChatGPT does when it chats with you. Instead of treating each part of a conversation separately, it keeps track of what was said before to give better and more connected responses, making conversations smoother and more natural. But how do you build on these connected responses? That happens when you combine word boundary detection and word clustering. Word boundary detection involves figuring out where words start and end in a sentence, like finding spaces between words, while word clustering groups similar words together based on their meanings or usage. These experiments help networks understand how words relate to each other in a sentence so that it can recognize not just words, but also their connections. It understands that words like run and running are linked even if they look different, helping it grasp the meaning behind words and sentences better. AI shifted towards bigger and smarter networks, thanks to the work of Hinton and Sutskever in 2011. They made a breakthrough by using huge amounts of data to predict the next letter in a sequence, which led to the introduction of larger networks that could handle more complex tasks. It was like giving AI a bigger brain, allowing it to understand patterns in language better, because these larger networks learned from lots of data to get really good at predicting what comes next in a sequence. To fine-tune this sequence, this is where the self-attention mechanism comes in. The self-attention mechanism, like an attention layer, helps AI focus on which words or parts of a sentence are crucial to understand and remember. It's like giving AI a spotlight to shine on the most essential bits of information, tackling the problem of handling big chunks of data all at once. This clever trick allows AI to process long sequences more effectively, making it smarter and better at understanding the context of the information it's given. Coming back to GPT-1, it was the first iteration of OpenAI's generative pre-trained transformer, learned from a broad range of internet text. Trained on a diverse mix of books, articles, websites, and more, it absorbed patterns and information to predict and generate human-like responses. But it wasn't until GPT-2 came into the picture, revolutionizing AI language models. With 1.5 billion parameters, GPT-2 was very good at understanding language and generating text, and was used for a variety of tasks, such as translation, summarization, and question answering. It performed well on benchmark tests, demonstrating its effectiveness across different domains, and its improved architecture set a new standard for natural language processing. But then came GPT-3, which shattered all records. With over 175 billion parameters, it enabled unparalleled understanding and adaptability using a technique called in-context learning, which allowed it to grasp the nuances of a situation and craft appropriate responses. Not only that, but it can also identify complex patterns across languages, tasks, and domains, enabling it to generate human-quality text and solve problems effectively. In benchmarks, GPT-3 has consistently outperformed its predecessors, and that's exactly why it's become the go-to AI tool for most users now. ChatGPT made AI accessible to everyone, opening its potential to a wide range of consumer products. Its ability to have natural conversations made it popular and improved user experiences across different platforms. However, researchers wanted even better interactions, so they created InstructGPT. This new model is like ChatGPT's sibling, but it's better at following instructions and completing tasks precisely. Language models are no longer just good at understanding and generating text. They can now tackle complex tasks in virtual worlds. Researchers have shown how these models can navigate virtual environments, solve puzzles, and even interact with objects. This opens the door for real-world applications across various industries. For example, AI-powered virtual assistants are already being used in customer support, while chatbots powered by language models can provide seamless interactions. These models are also being used for data analysis, content generation, and personalized recommendations, and as they continue to evolve, their integration into APIs will continue to boost productivity and efficiency across several industries. GPT-4 takes the latest trend in AI to the next level, building bigger and better models. These models, with more parameters, will be able to understand and generate text that is more nuanced and aware of context. The ultimate goal here is to create an oracle of AI, a system that can understand and solve problems just like a wise and powerful being. However, there are a lot of ethical considerations tied to it too. Researchers disagree on how much large language models actually understand. Some think they're almost like humans, while others think they're just good at copying patterns. This disagreement makes it important to think carefully about the ethical implications of using these powerful models, because while AI has definitely made things easier, can it soon take over humans? Doug Hofstadter has some concerns of his own.
If I were to take an hour in doing something, the ChatGPT-4 might take 1 second. It's quite terrifying. It felt as if not only are my belief systems collapsing, but it feels as if the entire human race is going to be eclipsed and left in the dust.
Sometimes this philosophical debate is like the old Turing test. Can a machine that can fool us into thinking it thinks actually be considered thinking? Well, experts like LeCun don't really think so, but despite that, the models are so good, it's hard to tell. This debate shows that we need to figure out how to tell the difference between simulated thoughts and genuine understanding. Because even though ChatGPT is incredible at holding human-like interactions, it cannot fully embody the soul of a human. No matter how massive or diverse its training corpus may be, at the end of the day, ChatGPT is just a large language model designed by humans for humans. But the question is, as AI continues to advance, will it finally break the fourth wall and be its own being? Let us know what you think in the comments section down below. If you like this video, please give it a thumbs up and subscribe to our channel for more videos just like this. We'll see you next time.